Okay, Pierre, the floor is yours, and thanks again for coming.
Thank you very much, and thank you for having me. And as Tobias said, I like to keep this interactive because really, number one, I have a French accent. I haven't lived in France for a long time, but I do have a very heavy accent. And you don't want to listen to me slide after slide after slide after slide for too long. So we'll try to make that a little bit more interesting. Let me see if I can actually show my screen. Do you see my screen now?
Not
Hello?
yet.
Not yet?
Not yet, Pierre.
It should show.
I think
Still
Pierre,
not?
give it another go, Pierre. Yeah.
Okay. This, of course, worked during the test, but test and share tray. Yeah, I'm clicking on a window. Still nothing?
No, actually not. That's really exciting, people.
Yeah.
So we did a test so that this wouldn't happen, but of course it does anyway.
It doesn't.
So usually what helps when this happens, because this happens every now and then, is actually for you, Pierre, to leave and reconnect to the meeting, if that's fine with you.
Okay, let me try that.
Super, super. See you in a bit.
Okay, here we go.
It's
Sorry, guys.
It's the old reboot, right, Victor?
Yeah, you guys are all familiar with this, I guess.
I can hear you. That's interesting. Supposed to have quit the meeting. And
you're probably live somewhere else, Pierre.
Now it's Ian he has left.
You're right, Jefferson. It is the Microsoft maneuver.
Yep.
Okay, I'm back.
Hello, 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 hello.
Okay. And let me see, try to share again, open share tray.
There we go.
Yeah.
Superb, huh?
If at first you don't succeed, just reboot.
Yeah. Well, that was easy.
Yeah.
You need to take it away, Pierre.
Okay, thank you. Okay, so again, thank you for having me. A quick introduction. So I'm a software architect based in Glastonbury, Connecticut, as my accent doesn't indicate. And I've had quite a few years in architecture, application development, and the like, mainly in financial services. So Tobias, I could relate to what you said about starting a startup for a bank. Been there, done that. In my case, it was more for an insurance company, but I'm sure that the issues are probably similar. I was also at one point, not so long ago, the chief enterprise architect for a very large company. That's an interesting experience. And one thing that was also interesting was at some point, I led the Technology Innovation Center for that insurance company. So it was a very interesting experience as well. And some of those experiences actually reflected in the latest book, the Continuous Architecture in Practice, Chapter 9. So if you ever fancy reading it, and if you look at Chapter 9, you'll see what kind of things I went through. So back in about 2015, a friend of mine and a colleague of mine called Murat Herder and I decided to write a book. And that book became the blue book that you see on the thumbnail, the Continuous Architecture book. And the idea of a Continuous Architecture was really, Murat and I were consultants at the time. And we were a little bit puzzled by the fact that you had two factions. One faction was the traditional architects that really wanted to develop everything, to create the architecture upfront. So what's became known as the big design upfront. And on the other side, you had the agile people that say, no, not that. The architecture should really emerge as you go. Kind of think of a whale coming out of water, right? And we say, well, maybe there's something in between. So that became that book, the Continuous Architecture book. And about 5 years later, we decided, well, it's time for a refresh because technology changes. And also, instead of having a conceptual book, we actually wrote a book which is much more practical. And the book, Continuous Architecture in Practice, is organized around a quasi-real-life case study. So kind of interesting. Okay, so enough about me. And as you can see from the picture, what I do when I don't deal in software architecture is I'm on a boat and I sail a lot. So I sail around here, not the North Sea. It's basically Long Island Sound and the Block Island Sound, but still very exciting. Okay. So before we go further, a little bit of a disclaimer here. Okay. Those are my views. What I'm going to talk about is my views based on my experience, mainly in financial services. Okay. And by all means, others may differ and will differ in their views. And that's healthy because I don't have, I don't have the final word on anything. I don't have the final word on especially not on architecture. And I think it's important to contrast different views on the same topic to really move ahead and make progress. Okay, getting into the presentation now. I'm stuck. Excellent. Oh boy. Looks like my machine is stuck now. Let me see if I can try to get out. I think today is going to be an interesting day.
I think you have a very good mindset, Pierre. Did you get something on me requesting control?
I just agreed to that. You have control.
So let's see if I can move it for you. Not. So I'll stop the control because that didn't help anyone.
Okay.
And if you move back to the to the PowerPoint. And
my keyboard is totally stuck. I have zero control right now.
And you can't exit presentation mode either?
No. Let me see what I can do here.
It's very exciting, guys.
Oh, yes.
There we go.
Yes.
Patience is a virtue.
Yes. Okay, so we can move. and coincidentally, the next slide is actually very appropriate because it talks about the 5 ages of software systems and hopefully showing progress. I'm not sure based on what just happened that we have a lot of progress. But anyway, so I'm sure everyone is very familiar with this kind of slide. So we basically 1980s, and some of us, at least I'm old enough to remember those days, we had basically big system on mainframes. And at the time, we didn't have too many architecture or software engineering questions. Basically, you put your software on a mainframe, and the mainframe vendor, most of the time IBM, will take care of the rest. Those were simple things, limited, but simple, no architecture. And then some vendors decided to try to break through the glass house, as they call it. And Digital, if some of you remember that company, Digital, they decided to basically start distributing those systems on servers. Their goal was to sell, of course, hardware at the time. Hardware was a profitable business. And so software architecture started at this point becoming a little bit more important because if you had a bunch of servers, well, you had to connect those servers somehow. And you started talking about things like network latency, which honestly on a mainframe we didn't care about. Okay, so now you're talking about something a bit more complicated. Then came the internet. Okay, and suddenly you could connect across companies, you could connect across countries, that became really, really exciting. Okay, and moving on, basically, the next logical progression was the internet and the cloud. What people started calling the cloud became the system. Okay, I still remember a company called Loud Cloud, and which is long gone now, which was started back around that time, and nobody knew the beauty. Nobody knew what a cloud was, but it sounded cool, so people embraced it. And now, of course, with the emergence of AI, we finally have today what I would call intelligent connected systems, where systems actually can do more than just connect, and you can actually starting having ecosystems of almost I would say self-managing systems, kind of frightening thought. Now, what's interesting about all this is that very few of us write 100% of our own software. I mean, we all use packages, whether it's open source or commercial. And integrating packages has always been a big part of software architecture and software development. But what I'm seeing more and more is instead of integrating packages into our software, if you take Salesforce, for example, to name a few, you start integrating your software into those packages, which has some very interesting consequences on really software architecture. And what's, yes, it has been 40 years. Basically, you see that evolution. And technology has evolved a lot. And the question is, the way we develop systems, software applications, may not have developed fast enough. And certainly architecture has not developed fast enough to follow. So that's a little bit of a constraint. Tobias, do you have any questions at this point?
Nope, no questions so far.
Okay, perfect. So let's move on. So what happened is we now have a bunch of software architecture challenges, okay? And you'll see in that presentation, I'm very careful about not necessarily talking about architects, but more talking about architecture and really architecture practitioners. And you'll see in the last few slides, this is the suspense, but kind of cliffhanger. You see why I'm trying to stay away from the word architect. You'll see. So people, and if you ask business people, as this in the States, okay, you find out that basically people have a problem with what they call architecture. And the first problem is, well, people who do architecture tend to focus on technology details rather than business context. So remember when the cloud came out, okay, and basically AWS came out and Amazon was not selling books and things, although they still do a good job at that, but their main business became the cloud, okay? People really wanted to architect system to cloud. It was important to move system to cloud, okay? For those of you that worked in financial services, remember Capital One basically deciding to move all their systems to the cloud. And we all know how this ended up, not too well. But the idea was, let's go to the cloud. And kind of forgetting what really architecture is about, which is solving business problems. So that's a challenge. Logically, as a result, you now have a perception of architecture as not adding value. If you don't solve business challenges, well, you're not really adding value. If you're not adding value, that's a problem, okay? Compounding to that, going clockwise, is that the practices may be too slow. You all have this vision of an architect, basically in somewhere in the ivory tower, okay, doing a lot of diagrams and things like this. And the more complex the diagrams, the better, because you get to a point where the architect is only one can understand their own diagrams. And that's job preservation, okay? And, that's great for the architect, not so great for the rest of us. And then kind of the last nail in the coffin is that some practitioners, on top of that, even if cloud is really becoming mainstream now, may still be uncomfortable with cloud platforms. Okay, we feel better about having systems into our own enterprise. We don't talk too much, we can't really control what's happening in the cloud. So that's no good. So you see those 4 challenges. And how can we respond to that? And that's how basically we started thinking about continuous architecture and say, how can we solve that? Any questions so far? Nothing?
No questions so far. I think
Okay.
it's crystal clear for everyone, right?
Yes, yes, too close to reality, I'm afraid. So let me tell you a little story here. You may remember an old movie, Marilyn Monroe, called Some Like It Hot, right? And I think that movie was done in the 60s, if memory serves. And that movie featured a very iconic hotel called the Hotel del Coronado, which is in California, south of San Diego, and it's in Coronado. That's where the name comes from. That hotel is actually a fascinating hotel. I don't know how many of you have a chance to see it. If you ever go to California, and if you're in that neighborhood, please go and see that. It's quite amazing. That hotel was built around 1880, okay? And it's a wooden structure. It's all made of wood. It's very large. At the time it was built, it was the largest resort in the world. And what's special about that hotel, talk about continuous architecture, they had an architect initially, which I believe he came from Canada, and he had plans. But the plans were quickly forgotten as soon as they started building. So basically, he had plans, and I can imagine basically a scene, they are by the Pacific on a beach, and with this was built mainly by Mexican workers. And the architect and the workers are around the plants, and they are drawing things in the sand, trying to figure out how to build that hotel. So since 1880, that hotel has been basically changed, re-architected, removed, refactored, in a very agile way since 1880, and this is what it is today. So let's assume that we are basically a building company, we're a construction company. And we just got a very wealthy customer that is absolutely fascinated with the movie, Some Like It Hot. By the way, in the movie, the hotel is supposed to be in Florida, which is not. It's in California. But it's fascinating with the movie, and he wants his own hotel. He wants a replica of the Hotel Del. So how can we do that? Remember, there's no plans. You can't really go back and look at the plans, because the plans, I don't even know if they exist still, but they will be totally wrong anyway. So what happens is, we got two factions. We got the agile developers that say, let's start building something. Very much no plans, nothing, just look at it and just build. That's one way to do it. Unfortunately, the result may not be exactly the replica of the Hotel Del. On the other hand, my enterprise architect says, wait a minute, okay, I want to really understand how this was built. I want to survey. Let's create a 5-year plan on to do that. The chances are in 5 years, okay, my customer will be long gone, and therefore I don't have any business. So the point of this little story is that continuous architecture is really about trying to bridge the gap between the two. This has been, at this point, probably, and I'm probably underestimating the time, this has been a 20-year fight or 20-year tug of war between the left and the right, okay, between agile and enterprise architect, saying the enterprise architect saying we need to basically always create an architecture upfront. And by the way, things change all the time. So the chances are by the time you're done creating your architecture, you miss the boat. Okay. And the agile developer saying, well, the architecture has to emerge somehow. Okay. Well, that's okay until you realize that systems have to abide by what I call quality attribute requirements. Okay. Things like scalability are very important. Things like resilience are very important nowadays. And if you just start building, you may actually miss the boat. Yes, I know you can refactor, but refactoring could be expensive. And refactoring could amount to rebuilding the whole thing again and again. So there has to be a balance between the two. And that's what continuous architecture is about. Any questions on the Hotel Del or that little story?
Yeah, we have a question here, Pierre. So it's from Kuram, and he's asking, is the perception and need of architecture of architects changing in the industry, especially in the agile community?
Yes, absolutely. So yeah, very good question. Thank you, Graham. What I think is happening is that more and more, okay, the enterprise architects are realizing that the 5-year plan is not tenable. It's not, and people are really looking at that and saying, I can't really do that. Okay, the agile, yes, definitely was a great idea when it started, but now more and more systems need to be resilient, systems need to be scalable. And that doesn't do the trick. And you can't always basically refactor. I mean, one little story I love to share is refactoring is a great thing, except when you can't anymore. For example, if you build a system, you selected a database. Okay, let's say just you selected MongoDB for your database. And you decided down the line that MongoDB was not what you should have done for scalability or performance or whatever reasons. Okay, what do you do next? It's kind of hard to unbolt a database and put a new one, let alone convert your data. So people are realizing that clearly there's a need for something in between. And you'll see at the end, my last slide has a list of books which I found myself very interesting. And you see how many books were written in the last 10 years about that need to bridge the gap. So I think definitely, yes, the perception is changing.
I have a follow-up question, Pierre,
Sure.
on that. So if you're saying kind of that the enterprise architect must really sort of skip the 5-year plan, is there still room for a Northern Star when it comes to architectural question, or how do you make sure you keep alignment over time, or is that not needed?
So we're going to talk a lot about that in a few slides. So if you could hold that question for a few moments, because that's really what this is about. You still need to do some design upfront. There is no getting out of that. The question is how much should you do versus how much should you defer as you go. And that's basically there's a fine balance between some design upfront or no design upfront. You really need to strike that balance. So if you hold that question for a few moments, we're going to talk more about that. Okay, so let me move on a little bit. So what is that thing we call continuous architecture? And from the start, okay, the way we defined that was basically we wanted something which was principle driven. So we came up with about 6 principles, and we'll talk more about that in a minute. And the other was none of those principles are really new, and you're going to recognize some very quickly. But the idea was to put them in one place and to guide the practitioners with those principles. The second thing was a toolbox. Okay, every architect has basically a set of tools, and basically the idea is to catalog those tools. And also what we have seen emerging more and more was the architectural tactics. Those are actually becoming more and more important. So that's part of the toolbox. Okay, if you remember the patterns were basically definitely very important, and they were probably emerged about 20 years ago. Patterns morph into tactics. Tactics are a lot easier to use than patterns. Let's put it that way. And then you have those essential activities, okay, which are basically for us, it's really the key thing to doing architecture, basically. Focus on the quality attributes. Drive architectural decisions. You'll see that one of the points I'm making is decisions are probably the most important thing that an architect can do. And it's not really, yes, you need to have diagrams, but those things are not really important. Decisions is really what remains. Technical debt. Okay, every decision creates technical debt. Okay, some create more than others. And technical debt is not necessarily a bad thing, but it has to be repaid. If you don't repay it, that becomes a bad thing. And then the feedback loops. This is something that's absolutely critical. You need, once you put the system into production, you need to have a loop that helps you understand and fine-tune your decisions. And those 3 things, the principles, the toolbox, and the activities, have to be applied in your context. Continuous architecture is not a methodology, and we certainly don't want it to be a methodology. It's more, I would say, a set of things that you apply to your context, and context, culture, size, location, industry, and your development approach. So if you kind of move those 3 things or join those 3 things together, yes, that works. So what we're going to talk more about today, we talk about the principles, we talk about the tactics, as well as 2 of the 4 essential activities. So any questions about that so far?
No questions on that. It's a follow-up question that Jonas had on the last slide, but maybe we can summarize that a little bit. And I think it's clear what you mean when you say no upfront architecture. So
yep,
we should carry on.
And again, we're going to talk much more about that because remember, David initially the way this presentation started is David reached out to me on LinkedIn, and his question was exactly that. His question was, how much design activity should you do upfront versus ongoing? So we're going to talk a lot more about that, I hope. Okay, so principles quickly, and honestly, none of them are going to sound very earth-shattering. They went earth-shattering in 2016, and they still not. But the important thing is to keep that in mind. Okay, products, not projects. That's something I'm sure I don't have to sell you on. The best way I can explain is projects are really short-term things. Okay, although some projects tend to last a long time. Well, if you think products instead of projects, you start taking a long-term view. And also, you start thinking about roadmaps, you start thinking about product management, and you start thinking about solving problems for business, which is really what this is about. So as much as possible, try to think products, not solutions for projects. I know it's not always possible, but that's important. The second one is quality attributes drive basically architectures. Okay, that's a very important thing, not functional requirements. Any blob of software can implement functional requirements, but quality attributes is what really defines your architecture. By the way, you'll hear me using quality attribute requirements a lot. Okay, I don't like I know some people talk about non-functional requirements. To me, somehow the term doesn't ring right to me because non-functional. Well, what does that mean? Well, quality attributes is really clear. Okay, and as you see, what we're seeing with digital systems now is the emergence of 4 quality attributes, or 5 actually, I'm sorry. Security, scalability, performance, actually it's 4, I'm sorry, I can't go to 5 clearly, and resilience. And those are becoming more and more important. Okay. Number 3, that's another one we're going to talk a lot about today. Delay design decisions until they're absolutely necessary. The idea is you base your design decisions on quality attributes requirements, which are themselves based on facts, not guesses. Think scalability, okay? And I'm using scalability on purpose because it's really an interesting quality attribute. Scalability requirements are sometimes defined as, well, the system must be scalable. Well, thank you very much. What does that mean? Okay, unless you give me some actual numbers, I can't design a system for you. Okay, and don't tell me the system is going to have to be scalable for gazillion transactions. Well, when exactly do you expect to reach a gazillion transactions in your lifetime? Probably not. So why are we building a system for that? So this is really about understanding why you design, as opposed to making decisions just in case. Okay, remember things change a lot, which leads us to number 4, which is try to architect. I know it's very hard, but try to architect as possible for change. Okay, and one way to do that is leverage the power of small. So try to do small things, but not too small. Okay, because microservices were a great example where people basically said, well, microservices means very small, so we're going to do. And what it did was it created nightmares in terms of inter-service communication, which caused performance issues. Okay, so again, there's a little bit of balance here, and that's why architecture is not really a science. It's really more an art than a science. Number 5, don't forget test and deploy. Okay, if you're going to architect for scalability, testing is a royal headache. So try to, when you actually architect your system, try to think about how am I going to test it. Deployment. If your system is going to run on the cloud, well, you better architect it for the cloud. Or else if you try to architect a system, independently of anything, and you port it to the cloud and cross your fingers and hoping things are going to be great, well, good luck with that. That's not going to work very well. And number 6 is, of course, Mel-Conway's, or my interpretation of Mel-Conway's law. I'm sure that a lot of people heard of Mel-Conway. He passed away quite a few years ago. And the idea is try to avoid communication issues in your teams. Okay, let's say if you're a traditional architecture, 3-tier, right? Front end, mid-tier, and back end. And you have a front end team a mid-tier team, and a back-end team, things are not going to work very well because people are going to have problem communicating. What if you do more a full stack approach? And that became basically a lot of job requirements nowadays look for full stack developers. But if you take a full stack approach and say, my people are going to be conversant with front end, mid-tier, and back end, things are going to work very well or much better. Now, not easy to find people that can do that, but it's much easier to find people that can do that than to try to solve the communication issues between the 3 tiers. Questions?
Yes, a couple of questions.
Sure.
So first of all, from Judas, and the question is: do you think the Conway's law principle, or principle number 6, is enough to achieve reusability of components and long-term efficiency of architecture?
Wow! So that's actually a bunch of questions in one. Thank you very much. Okay, the first question, I will actually answer the question by another question. Do you think reusability is really the goal? And I think, honestly, I don't have an answer to that. Reusability is a very interesting concept. Okay, certainly something that, in my experience, senior management loves to talk about reusability. People want to reuse because reusability, hey, if I can reuse, okay, in theory, especially if I don't know much about details, okay, I can save a lot of cost. Well, yes and no. It turns out in order to have reusability, you need to be able to predict what your software is going to need to do. Okay, I don't know about you, I don't have a crystal ball, and it's very hard to me to predict what my software is going to do. Okay, so if I want, for example, if I take an example, and let me take an example in insurance. Okay, if I work in insurance and I probably have a bunch of line of business, okay, personal insurance, commercial insurance, and let's say claims. Let's keep it simple. And if I want to reuse things between even commercial and business insurance, commercial insurance and personal insurance, I will have to predict where personal insurance and commercial insurance are going to go. And believe me, it's hard enough to predict where personal insurance is going to go, where both of them are going to go, and what's going to be common between them. It's really, really hard to predict. So reusability, people also don't define that necessarily very well. Do they mean reusability of code? Do they mean reusability of design? What reusability? And I think reusability of code is a little bit of an illusion. It's very hard to implement. And when you finally created something which is reusable, a couple of things are going to happen. One is people who are not part of a team are going to resist reusing. That's totally human, totally normal. They hate when architects drop on them things like, okay, now this is great, just reuse it. Yeah, right, I'm going to show you. And that's the first thing. The second thing that happens is how things change all the time, and how to change these common reusable components. They have to be torn in a lot of different dimensions. So that's kind of my take on reusability. Now, I know that there are some success stories. I haven't been associated with too many of those. Now, how does that relate to number 6 or the Conway thing? Okay, certainly, if you had teams that cut across all the possible groups in enterprise and they work together, okay, you could, in theory, achieve reusability. In practice, those teams for a large enterprise will be very large. So how do you work together? I'm really not sure. So I don't really have a good answer to the question, but just to say, be careful of reusability because that may not be the goal.
Thanks, Pierre. I have another question on the principle number 2, focus on quality attributes, not on functional requirements. Pelle, hi Pelle, by the way. He says he's heard an alternative term, and he says cross-functional. And to me, cross-functional, I've heard it in a different context, but is that a word you're using to describe what you're saying here?
You could use cross-functional, although I haven't come across the term. What most people use is quality attribute or non-functional, yeah. Which is cross-functional. I mean, so long as they mean the same thing. I mean, the names are not very important. What's important is how you actually document those things. Okay, so if you're going to say, for example, my system must be scalable, or my system must be able to handle a gazillion transactions a second, well, you haven't really documented anything. So we're going to talk about that a little bit. Documentation is actually critical because remember, qualitative attributes are going to drive your decisions. Okay, decisions is how you apply your tactics, and that's what drives your architecture. So if your qualitative attributes are not well defined, guess what? The whole, it's like a domino effect. The whole thing is going to crumble. So you really need to spend time. It doesn't matter what you call them, but you really need to spend time on really documenting those things. That's why the term focus is so important.
Okay, sounds good. So there are a couple of different things here, but first of all, I want to sort of echo back what Jefferson says. If you want to, on the topic of modeling the organization after the system you're working in, there is a great book called Team Topologies, but one of the co-authors there also was with us and did a presentation. We have that live on our YouTube channel, so you can watch the talk there. Continuing on the Conway law, Kuram has a question. Most organizations are not aligned per Conway law. What an architect convince or drive organization change? I'm afraid it will not be taken well by many managers in the company. So my interpretation of the question is, have you come across different situations where it's hard for an architect to propose organizational changes?
Yes, absolutely. Definitely. So remember, we're going to do one thing we're going to do in this presentation is we're going to do away with term architect. And you'll see at the end what happens. Because architecture is migrating from a role to a skill. Okay. And basically, architecture becomes the team's responsibility. So the moment you make architecture team responsibility, it becomes much easier to change the dynamics and suddenly to solve communication. But to answer your question, basically, yes, the Conway law is really hard to implement and there's a lot of resistance. But my answer to that will be, well, if you don't really want to do that, do you realize the cost that you're incurring by having bad communication lines? And the cost is, we all know what happens. You have a team developing let's say a nice front end, and a team developing a nice set of services in the mid-tier. And they are both happy because unit tests are going well and everything is fine. And you get into integration testing and nothing works anymore. And everybody throws their hands to the ceiling and say, my God, what happened? Well, what happened was you didn't talk to each other. And then the same thing happens between the mid-tier and the back end. So the cost of not using Conway's law is really that when you do integration testing, very bad things are going to happen. And integration testing is usually done traditionally. We all know about shifting left, which is basically very important as well. But people necessarily don't do testing when they should be doing that. And testing is traditionally done a little bit at the end of a development cycle. And as a result, what happens is that you get huge delays at the end. That's a cost.
Cool. Sounds cool. We got two more questions on this round, but one I think I'm going to refer to later because I think you're going to answer Carl's questions on big picture planning. David had a question on the topic, almost a topic of what Luda said. Do you see a trend moving away from DRY, don't repeat yourself, to architecture more focused on minimizing dependencies and allow more copied code than before microservices?
Minimizing dependencies. Well, yes, we all would love to minimize dependencies. Okay, definitely. I mean, dependencies are something they are constraints. They basically are going to bite you no matter what. Right? Minimizing them is not always easy. Okay, for example, I take an example. Okay, if your enterprise has decided to use Salesforce, okay, you have a big dependency on Salesforce. You can't go around that one. You can't just say, I'm going to ignore Salesforce. Okay, what you're going to find out is you're not really going to integrate Salesforce into your systems. It's more about integrating your systems into Salesforce. And that creates a big constraint, a big dependency. So I agree that we need definitely to as much as possible to minimize your dependencies. But open source is another one. Okay, we all have to use open source. There is no way around that. Okay, now by using an open source module or an open source service or an open source piece of code, what happens is you bring in some dependency on whoever wrote that code. Okay, you may have some security issues that may or may not be understood, and on and on and on. So yes, I agree. I mean, I definitely would love to minimize dependencies. I just don't know that it's always possible.
Yeah, David is nodding as I think he understands the concept, right?
Yeah.
Okay, carry on.
Okay. So let's talk a little bit about essential activities, because that's something we didn't talk at all. We kind of talked about it a little bit in the first book, but this really became the big thing in the second book. And the whole thing about your quality attributes are going to drive your architecture decisions, clearly. But also understand that when you make a decision, okay, you're going to add or remove technical debt. And your technical debt is going to prioritize your decision as well. So technical debt has to be always understood and present. Okay, one of those things, kind of silent partner. If you don't really think technical debt is going to come and have a big effect on you. So feedback loops are very important. And feedback loops within production environment and the three quality attributes, technical debt and decisions at the top, are critical because they really measure the impact of decisions on the production environment. That's a critical thing. On the other hand, understand that your decisions will have an impact on technical debt. Okay, some decisions, such as the selection of a database, may be hard to reverse. So some decisions are almost, you can't really get out of them. Refactoring is not always possible. So understand that basically decisions carry technical debt, understand the quality attributes drive decisions, and understand that your production environment need to inform your, basically, your decisions and your quality attributes. It's very, very important to understand that. And that's kind of the point of continuous architecture name. Okay, always things don't stop because you put them in production. Things, basically, moving in production is just step one. You just have to understand that's a full circle. Questions about that? No?
No questions.
Okay. So let's talk about quality attributes. Okay, so of course, kind of stating the obvious. Okay, requirements will fall into two categories: functional and quality attributes. And functional, they are nice and they are usually well documented, which is great. They are not very important for the architecture. For the architecture, is what matters is the quality attribute requirements, which are unfortunately not well documented, and that becomes a problem. Okay, they drive the design. Okay, how well they are known determines how much design can be done in front. The whole thing is don't design on things you don't know or guesses, because problem with guesses is most of the time they're wrong. And then what happens is you start over engineering things scalability for no good reason. Okay, and then my four quality attributes, which are honestly, security was always important, but we used to think 10 years ago that security was a problem of the security team. Well, security is no longer the problem of the security team. Security is everybody's problem. So it's very important to understand that. Scalability is interesting. 10 years ago, scalability was not a big issue. Not too many people were talking about scalability. They would talk more about performance. Things have changed lately. I mean, basically the big e-commerce, social media, internet companies, things like Google, Amazon, Facebook, they claim, and we know they have systems which are amazingly scalable. Okay, so scalability becomes suddenly now, we all need to design scalable systems. Well, the problem is we don't necessarily know how. Okay, and using the recipes, the tactics used at Facebook or used at Google may not work for you unless you Google, of course. Performance was very important, but it's certainly even more important. And then resilience. Resilience is, or availability, if you prefer to think of it that way. Resilience is really becoming so important now. I mean, the story I like to tell about resilience is in about last year. Okay, trading by retail investors became very, very commonplace. Okay, most of the large investment or much of the large wholesale houses like Fidelity basically brought down the commission to zero. And of course, Robinhood came to the fore, and everybody was ready. What we found out, and this is also linked to scalability, what we found is in the hottest days when the market was gyrating wildly, okay, what happens is when people really wanted to quickly sell or buy, this is when systems started going down. There are some very interesting outages of Robinhood for last year and even early this year. And this is, of course, a problem because if you try to trade and your system is down, well, you got a problem here. Okay. Any questions about those quality attributes?
So, in the context of the quality attributes, how would you comment on technical depth? How do you manage that, or does that even have a place here?
So, technical depth for me is more linked. If I go back one slide, let me see if I. Whoop! Don't tell me that. Talk about resilience. So I think we crashed again.
It's the beauty of Teams, right?
Yeah, Victor, please help.
Have we crashed again?
Yes, we have crashed again. Just as I talk about resilience, which is a perfect. This is you couldn't time it better than that.
No, I've nothing to do with this timing, unfortunately. So lastly, what did we do? I think you actually, so if you stop sharing and share again,
Okay.
it might help you out because you're locked in the PowerPoint, I guess.
Okay, let me see. Let's stop sharing. Share again. Yes. Okay. Thank you. That did work. Okay. So I'm sorry, Tobias. So back to your question. So if I go back one slide, actually, which is what I was trying to do, for me, and again, this is just my opinion, technical debt is linked to decisions, not to quality attributes. So not directly, at least. So quality attributes drive the decisions, and the decisions are going to impact basically the technical debt in both ways. So yes, quality attributes indirectly impact technical debt. But to me, the direct impact is you make a decision. This has basically a technical debt impact. By the way, there is an excellent book, which is in the last slide as well, from Phil Rushton, Robert Nord, and Ipsek Oskaya about technical debt. And I cannot more, if you're interested in technical debt, I cannot possibly more recommend that book. It's a great, great book. Okay, so if you haven't read it, by all means, get it and read it, because technical debt is extremely important. Tobias, did I answer your question?
Yeah, it's good enough.
Okay.
Thank you.
And what you see at the bottom is, and you see a couple of slides, a couple of blog entries that basically, and those are my older blog. We have two blogs right now because we have two books. So the older blog has a lot on continuous architecture requirements and great stories on that. Also, so the new book has a new blog as well, and all these links are in the presentation. And I haven't taken the time yet to move the old blog to the new blog, so I will do that at some point. Talk about technical debt, right? That's another example of technical debt. Okay. Okay, so let's talk about back to quality attribute requirements. Okay, so what we like to do, quality attribute requirements, is really to document them well. And honestly, the best way to do that, and again, that's my opinion, so don't take that as a gospel, but my opinion is the best way to document quality attribute requirements is to use a methodology called the ETAM for architecture trade-off analysis method collection, data time scenarios, and utility trees. And the idea is, if I take performance, for example, this came out of the example came out of Facebook. So I have a system called mobile shopping, and I want to really study performance, and part of performance is latency. So instead of saying my system must have high latency or low latency, what I'm saying is at launch, and that's when I create my scenarios, okay, I have a stimulus, a response, and a measurement. My stimulus at launch, we must be able to have 10 concurrent users to access the system at the same time, okay? In response, the system must be able to handle those requests with an acceptable delay. And my measurement is my acceptable delay means within 3 seconds. So it can be cumbersome to document that way. But believe me, when you start designing, it makes design much easier. So it's a case of pay me now or pay me later, but it's very, especially we come down to scalability, avoid like a plague, things like my system will be scalable, because it really means nothing. Okay, if you define exactly what part of the system will be scalable, are you talking about database scalability, application scalability, infrastructure scalability, and what exactly do you mean by those things? Being able to precisely document is a critical thing. And I included a link to basically, there is also a great book from the SCI on that, but you can also go to that link and get a lot of information about that methodology. So that would be my recommendation. Questions about this?
One just popped in here right now. It's a long question. I'll try to read it as it is. A question about Robinhood. How could any person in the company predict the influx of retail traders during the pandemic in quarter 1, 2021? Speaking in a general manner, the fact their software went down, isn't it the case that the company was hugely successful? Then they got extra funding to re-engineer those faulty models in 2022, whereas perhaps it would be premature to do so in 2019 and earlier, having maybe negative impact on other business features. Or should the architecture of trading platforms support traffic boosts of 100 to 200 times from day one? So I guess this is about premature optimization or not, and when should you decide to meet those requirements?
Yeah, and that's an excellent point. I mean, that's absolutely, on one hand, I'm saying delay design decisions and they become necessary. On the other hand, this is a great example of, well, how do you know? Because if you are Robinhood, okay, and if you look back at basically past of trading, okay, you're going to probably find out that, volumes were not expected very high. However, there's another angle to this discussion, which is another way to look at scalability is to look at business plans. For Robinhood to survive, okay, their whole business was retail investing. And if there were no retail investors, then there is no business and they may as well close their doors. So the whole question about Robinhood becomes, well, if they want to be successful, they have to build an amount of scalability into their systems. Because basically, if they don't, then it's very much like saying, well, we know that we need a lot of volume to be successful, but we're not going to plan for the volumes. Therefore, no, we don't want to be successful. Kind of a paradox. That's one thing. Number two, you see when you get to scalability, there's much more to scalability than making your system scalable. There's also the other side of the coin, which is your feedback loop. You need to monitor your systems. And that's an important point of scalability. You need to monitor your systems and you need to make sure that you quickly find out what's going on in the system so you can react fast. And then the last part is basically being able to fail gracefully. Okay, things happen. Your system will crash. That's a given. There is no system that won't crash. I mean, if there is one, I really want to meet the architect quickly. So system will crash. If you know what to do, and if you build in your code, in your architecture, if you build what it takes to actually recover from those crashes nicely, then the impact of a shortcoming of scalability will probably not be as bad as a system just that quits and stops. And that's the whole point of resilience. Resilience is about admitting basically that you can't predict the future. That's impossible. So your system will crash. So what do you do when the system crashes? How do you gracefully get out of that?
Cool, thanks. I hope that answered your question, Martin, and I hope you're back from your around the world trip as well. Good to see you. Jefferson has another question.
Sure.
Any experience documenting quality attributes requirements as SLOs?
I'm sorry?
SLOs. So that's Jefferson, you're much better at explaining SLOs and SLAs and the differences. You care to take the mic?
Right, I was not expecting that.
Right?
Okay, yeah, but service level objectives is like a term like from Google. Yep. I think like they came up with it like in the site reliability engineering book. I think it was the first time that I have seen it. Yes. And of course, like they pose that as kind of like a description, a concise way to make a commitment to maintain a particular state of the service, like in a given period. I think that they mentioned that, like, at least I foresee, compared to the quality attributes requirements that you exposed in the slides, is that they don't have like time windows, as you mentioned. It's just like current windows. We're just wondering if anyone there in the field have used like SLOs, like defining SLOs first to drive like the quality attribute requirements.
So I am familiar with SLOs, yes, definitely. Now I know what they are. So is the objective, yes. The thing, I haven't seen them used yet for quality attribute requirements. However, I think it's quite possible, so long they can be translated into actual scenarios and work. But remember, the timing, the measurement of the timings are very important, because if I just say acceptable delay, if you look at the slide, if I respond with an acceptable delay, well, that's nice, but what does that mean? Well, if I say within 3 seconds, now I can design a system precisely, and more important, I can test the system to basically respond to this. I think that at the end of the day, it doesn't really matter how you document your requirements, so long that they basically are precise. They can be, they have actual numbers associated to them, and they are testable. Requirements must be testable. If they're not testable, they're not very useful. So remember the architect for build, test, and run. Okay, basically keep a test in mind, and that's also the shift left story. You really need to bring a test to mind when you actually look at requirements.
Okay, thanks, Pierre. We're sort of running over time, but I'm not going to stop you, Pierre. I'm just going to tell everyone that if you have to leave, so of course use the law of 2 feet and leave. We're going to keep recording this, and we're going to put it out on YouTube. So you can find the link to our YouTube channel in the Meetup, Meetup page as well. So sorry for that, and continue.
Not at all. I mean, I think I'm enjoying this. I mean, this is great to have some useful feedback, definitely. So I'm going to try to. Don't tell me it's stuck again. Oh boy. Yes.
We know how to resolve it. You're good. Yep.
Yeah. So one more thing about, and we can go quickly about through that slide. Okay, requirements are all interrelated. There is no, and I couldn't possibly come up with a graphic that shows all the requirements. But basically, what's going to happen is scalability is going to impact availability or resiliency, performance. Okay, performance and availability impact usability. We all know that. Okay, but there's one that never talks about, which is cost. Okay, cost is not an explicitly defined qualitative requirement, yet cost is always there. In a real world, okay, in a world of non-digital world, okay, if you want to build a house and you hire an architect, it's likely that the architect is going to basically suggest a few options based on cost. Okay, we don't really do that in the technology world. We don't really offer our customers option based on cost. We start with cost and we say, okay, we hope we're going to make the budget. And we all know that most of the time we exceed the budget. So what? We just continue. So keep in mind that this kind of interrelation, if you change one requirement, you're probably going to affect the others. And you're probably going to affect also the cost of your system. Okay. Any questions on that? I think it's straightforward.
It's pretty straightforward. I have some comments on my private Slack here that it's very nice the way you bring up costs, and it's not usually something we talk about. So
yep.
a good thing to remember.
Yes, absolutely. Okay. Decisions. Let's move to decisions. So this is actually a very almost controversial statement. I think, and my co-writers think as well, that unit of work of someone does architecture is the decision. Yes, diagrams are important. Yes, all artifacts, but decision is really the critical part. And one of the most important outputs is really your set of decisions, which means that you have to document what if it's important, you have to document. So a couple of things about decisions, okay? Always document constraints, or as David pointed out, also dependencies are important as well, okay? Keep in mind that the architecture is not basically about necessarily the best solution. It's about finding a good enough solution, okay? Kind of Otto von Bismarck once said about something about politics is the art of compromise. Well, I paraphrase that and say architecture is the art of compromise, okay? Basically, it's very interesting that basically you cannot necessarily have the best of everything. You got to have compromise. So keep compromise in mind. Okay, explicitly address quality attribute requirements. We spoke a lot about that. And in order to be able to address them, they have to be documented and clearly basically described. Okay. It's very important to actually document all options and rationale for those options, for coming to a decision, to basically do that as part of the documentation. Okay, sometimes things should change. And sometimes, okay, an option which sounded not so good may suddenly sound much better. So keep that in mind, okay? Trade-off, of course. Well, if it's going to be, you always have a trade-off somewhere. Think, for example, security and usability, classic trade-off, right? Somehow something has to give, okay? And you can't really not have security. You can't not really not have usability because then you have no users. So you got to strike a compromise somewhere. And the last one is cost of reversing decisions. Okay, some decisions, unfortunately, are almost impossible to reverse. So understand what you're getting into when you make a decision. I think once you understand that, you may change your mind about that decision. Questions about that?
No questions, Pierre. I think it's a great summary of slides, and one thing that I really take with me is that it's all about making sure you can change, right? You
Yes.
make a decision, but you always make sure you can change.
Yes, exactly. But change is you're absolutely right, Tobias. But also understand that it's not always possible to change. I wish it was, but not always. Okay. So just an example of documented decision. So just a log entry. Really. So type, name, ID, brief description, options, and rationale. Okay. But also, what's important is also to actually document who made the decision and when, because accountability increases the trust, and this is also about trust. Okay, if you know who made the decision, okay, you're going to trust that decision. Well, if it was done by committee, well, maybe you don't trust it too much, or even if it was done by who knows, that's even worse. By the way, it's important to store this log somewhere. Okay, and there's no wrong way to do it. I've seen it done in GitHub next to a code. That's a great way to do that. I've seen it done, in all kinds of places. So long as it's documented, and so long as you know where it is, because you need to be able to go back. Okay, it's a great way because you may need to go back to a decision maybe 5 or 10 years from now. So, and you may have a good laugh when you look at those decisions. Questions about documenting?
Nothing in the chat.
Yeah, good. Okay, so let's kind of move to a little bit where David's original question, which is basically how much upfront design upfront and how much ongoing. So I like to keep that image in my mind. Okay, it's just one more image. It's about, if you're going to work on a piece of steel, you're going to heat it and cool it down. That's, the normal steel mill kind of story. It hasn't changed in probably centuries now. But keep in mind that the way I think about it is decisions early on, based on vague quality attribute requirements, may create a broken architecture. The same way as if you cool down a piece of steel too quickly, you end up with cracks in a piece of steel. So that kind of, when I try to decide when to make a decision, I keep that image in mind, and I say, wait a minute, I'm not going to create a piece of steel with cracks in it, but just a useful thing. Now, let me introduce a concept here, which was introduced in the first book, and we did not really elaborate this concept in a second book, which in the retrospect, I wish we had, and I will fix that problem by at least generating some blog entries about that, and perhaps at some point, who knows, we may write a third book, who knows. But the concept of minimal viable architecture. And this is so often associated with minimal viable product, which is, of course, a startup concept. But to me, it's good and bad, because the problem of minimum viable product is, at least in the States, there's too much of a culture of fake it until you make it, right? So you kind of, a minimum viable product, you create a product which is sometimes need to go to market quickly and need to gauge the customer's reaction to it. And things happen behind the curtain sometimes, okay? So you have some manual things and so on. The minimum viable architecture is quite that, okay? You don't have any, you don't fake it, okay? But it's really about what are the minimum set of decisions that you can live with and without mortgaging the future. So, of course, I go back to the excellent question about basically Robin Hood, which is, how do you create a minimum viable architecture of Robin Hood? Well, yeah, you could create a minimum viable architecture to handle a low number of trades. But on the other hand, if your business model and basically a surveyor company relies for high volumes, you probably want to take that into consideration when you do your architecture as well. So there's an art. It's almost, there's a very fine balance on what do we mean by a minimum number of decisions. So critical point here. Questions?
No question.
Okay.
But I really like the concept of minimum viable architecture. Nice.
Oh yeah. Okay, so since you like it, we have more minimum viable architecture. Okay, and let's say we want, think of it as growing a plant. Okay, so you start with a small number of decisions based on facts. Again, facts is the key thing. You act quickly to facilitate decision making. Okay, decision making should be should actually be a continuous activity. You keep on making decisions, but the key thing is you also don't want to surprise anybody. You don't want to disappear and reappear on architecture. It doesn't work that way. You want to communicate the plan, the progress, and all the decisions to all your stakeholders, including the business. And it's hard, but you have to make it. You have to understand what it is about. And there is this great quote, okay, which is complexity is a natural trajectory, okay? And it just will happen. You can't avoid complexity. What really the point of architecture is simplification is innovation by design. So think of complexity is something that naturally happens. It's like complexity to me is another form of technical debt. It happens, okay? And the art of the architect or the person who does architecture is really to simplify by innovation, and that's a critical point. Questions on this?
No, nothing in the chat.
Okay, so let's go to tactics. So we remember quality attributes, decisions. Now we move to tactics. So tactics, design decision that affects how the system implements one or more quality attributes. Okay, we understand that. The good news, bad news. So catalog of tactics do exist, and basically there are some references to the book. Actually, there is also a blog entry on tactics, a new blog, and I think I put the references to what I know, the catalogs. Unfortunately, catalogs are not, as many as I would like them to see them, and sometimes you really have to take a tactic and adapt it to your problem. So that's kind of the art. So example of tactics, and this I just took an example on resilience. Okay, and if you look at basically the system if you see TFX is the name of the system we actually build the book around. So that's actually a banking system, something Tobias you can relate to definitely. But the important thing, what you see in red in this slide, is basically some examples of tactics. So on the front end, you basically have request secret breakers. Okay. On the deployment module, you basically health check API, auto scaling, using a VM as a bulkhead. On a gateway, things like throttling, load shading, metric alerts, and bulkhead. Now, this is basically an example. That doesn't mean that those tactics are applicable to every situation, because they are not. Some of them are. Okay. Again, understand your requirements, your decisions, and then go to your tactics. Okay. But if you start thinking in terms of tactics, you start building a toolbox, and that will help you a lot to actually recognize the situation and say, okay, I've seen that before. This is what I know works, and this is what I know doesn't work. And this is kind of if you remember the concept of patterns, okay, to me, tactics are a simplification of patterns, and they are extremely much more easier to use. The challenge I always had with patterns was to basically document the forces for a pattern. That was always kind of a hard thing, at least for me. So tactics kind of solve the problem. Questions on tactics?
Nope, no questions.
No? Okay, so we're going to go to an example now. Scalability, one of my favorite. Actually, one of the chapters I wrote in the book. Okay, so what do we mean by scalability? So we can define that as property of system to handle an increased or decreased. People kind of forget that scalability can also go down as well. Important to say, by increasing or decreasing the cost of the system. Now you see why cost is so important. Okay, when you decrease the load, you should be able to decrease the cost as well. Something that people kind of forget. Okay, scalability requirements, you heard me say that many times, as poorly specified. That's a fact of life. Okay, and to make matters worse, as if we did it too. Okay, calling a system scalable is simplifying. Okay, it's oversimplifying. Okay, scalability has many dimensions. We need to qualify it. We may want to talk about application, data, infrastructure, and so on and so forth. Now, kind of spoiler alert. Okay, data is probably causes the biggest headache in scalability in my experience again. Okay, most of the scalability issues will probably come from data. To make matters a bit more complicated, as if, okay, some people sometimes confuse scalability and performance. Okay, performance is really about time and the system ability to meet its timing requirements. It's not scalability, although scalability has a direct impact, of course, on performance. Okay. Now, kind of bad news, good news for scalability. You need to look not only technology aspects, but business, social, and process. Because if your processes are not scalable, then it makes no sense to basically have a scalable system. Okay. And then the last one is some aspects are definitely outside the team's control. If you're going to integrate into Salesforce, for example, the bad news is you're going to be bound by whatever Salesforce does for scalability. Okay, keep that in mind. Questions on that side?
No, crystal clear.
Okay. So again, there's a blog entry on the scalability. And of course, the book goes into short. So how the hell do we architect for scalability? Well, first thing is think minimum viable architecture. Again, basically keep in mind principle 3, delay the decisions until they are absolutely necessary, but not later. Okay, always keep in mind those principles should be always nuanced. Okay, and then principle 5. Okay, testing for scalability is a royal headache, and if you don't think about testing for scalability when you architect, you're going to have some real big problems when it's time to test. Okay, by the way, some scalability problems basically are beyond what you can honestly test. And as you get, and the book goes much more in detail into that, the Simeon army from Google and so on and so forth. So not always possible to test. Of course, there are tactics, and we go into that in the next slide. Okay. Keep in mind that they're all related, and that's the 5th one, cost. Tightly related, we saw that. One common mistake is to think that scalability is the problem of cloud provider. It is not. Okay, software systems which are not scalable, okay, will not be scalable if you just dump it into the cloud. Okay, so don't think of the cloud as the solution to the scalability problem. It's not. Okay, and then the most important thing of scalability is monitor scalability and deal with failure. Okay. Sometimes you can't predict how scalable a system should be, Robin Hood, right? But this is no excuse not to monitor and not to deal with failure, okay? And basically automated mechanisms will allow you to avoid failure as much as possible. Question on that?
Nope, nothing in the chat.
Nothing in the chat. Okay. So tactics quickly, and I'm not going to go through each tactics. Basically, again, the blog has, and the book, of course, has much more detail than that. The thing to remember about tactics, I mean, data distribution, data replication, partitioning, sharding, caching, setless, microservices serverless, monitoring, and dealing with failure. Except the last 2, okay, those tactics should be taken with a grain of salt, because it's not because, for example, Google uses them that you have to use them. Okay, keep in mind tactics are linked to decisions which are linked to quality attributes. Okay, always understand the concept you're in, the context you're in. Sorry. Okay, the last 2 are the ones which are not optional. Okay, if you are serious about scalability, you've got to put some monitoring in place in your system up front, and you've got to be able to deal with failures. So basically, the whole concept of circuit breakers, governors, timeouts, and bulkheads have to be thought about. Those are decisions which, one of the few decisions that need to be made up front. Okay, to me, there is no optional capability here. You need to do those things. Okay. Also, one quick thing: be careful about serverless. I know serverless was all the rage, what, 2-3 years ago. At this point, yes, serverless functions are very scalable, but they are limited by the cloud provider, and they are also cold start latency to be an issue. So just something to keep in mind. Questions on this?
Nope. I can only second the 2 last ones. They're absolutely necessary, right?
Oh yeah, absolutely. Concluding, is architecture still relevant in today's world of agile, cloud, and DevOps? Well, yes, they are, because the architecture allows you to achieve quality attributes. I start sounding like a broken tape recorder at this point. Okay, we need to balance stakeholder concern. We need to make complex trade-offs, and to achieve cross-cutting concern across many independent parts. So architecture, this is the point of architecture. However, and this is the most important thing, architecture is no longer basically what it used to be, which is a big set of diagrams up front. It has now become a continuous flow of decisions. And I think that's a very, very important point to understand. Good so far?
Yeah, I think it's very good. Can I try and add something and,
Sure.
and put some more flavor into it? I think it's a flow of continuous decision that are also continuously revisited.
Mm-hmm. Yes,
Because
absolutely right.
Continuously changes, right? The world around us changes, and we have to, as often as we can, revisit those old decisions that we made. And sometimes we rip them apart and do another decision, right?
Yes, providing that we can afford to.
Yeah, of course, there's a price to it, right? But then again,
Oh.
you talked about the alternative cost and of not doing things, and so it's always
Exactly.
a yeah.
Always think cost. That's very important. So now, this is kind of a punchline of presentation. Do we still an architect role? And I don't think so. I think that architecture has become a skill, not a role. By the way, this was when I was chief architect at an insurance company. Okay, this was one of my last presentations. Can you imagine a room full of architects working for the company? And that's the point I made. So that made me immensely popular. You guys are out of a job, basically. Thanks for stopping by. But it's true. I mean, architecture is now a skill, not a role. Okay, we have basically a stream of decisions which are continuously revisited, not one and done. Okay, we favor definite principles, styles, and tactics of diagrams. Okay, we should delegate whenever and share whenever possible. Delegation is important. Okay, architecture is a teamwork. It's not one person anymore. Okay, kind of be lazy. I know it's kind of funny, but lazy. Do as little as possible and often, and adapt. And the last one is back to reusability thing. I don't think of reusability. I think more a shared common. Think of a set of things. Doesn't need to be code, but think of things you can share, basically. Tactics, for example. Quality attributes could be shared. Things that basically decisions sometimes can be shared. Things you can share across the enterprise, and maybe at some point we may get to a point where actually enterprises start sharing across. That would be cool to basically inter-enterprise sharing. So the punchline is really, yeah, it's a team now. It's not basically, you can't call anybody an architect anymore. Okay, you have IT professionals, call them engineers, call them, but they all do architecture. So it's very important to acquire that skill. Any questions on the chat before we go to the last one?
I think there is a question, but that's more, we can take that on the end. It's about what your book covers and not, so we can take that at the end. Sure. And Mark had he just echoes what you're saying. He think it's great words. So thanks for that.
Thank you. So actually we are at the end because the last slide is the one I kept on referring to. So those are books which are published in the last 10 years, give or take. Rosansky and Woods was published in 2012, so about 10 years. And they are all great, by the way. All these books are great. They don't necessarily agree with what we talk about today, and that's good. I mean, we need to have different aspects, okay? Keep in mind the last book, the Managing Technical Debt, because it's a very important one, okay? I love the Gregor Hope book, the Software Architect Elevator. That's definitely a good point. And of course, the Fairbank's book, Just Enough Software Architecture. That's a good one to keep in mind. So I'm done with my slides.
Thank you, Pierre. It was really nice hearing and watching the slides. Khurram has one final question, and I'll make it a little bit short. In your recommendations, any of the books, or if your own by that matter, deal with system designs? Khurram wants to know.
Any other books? Oh, no, other than the ones.
If they cover details of modern system design. Modern system design.
So out of those books, let me see. Definitely the Simon Brown books, which are 2 volumes. Okay, definitely deal a lot with system design. Okay, the Killing book also. Well, it's called Design It. So you kind of I gave away. The Killing book is also. Those are the 2 books. If you want a more design view, but keep in mind, Grady Butch said one day, and he's been quoted on that all the time. Okay, all design is architecture, but not all architecture is design. The boundary with architecture and design is really blurring more and more. So honestly, any architecture book will probably be heavy on system design, and vice versa. But those 2 books, yes, the Brown and the Killing definitely will be more design side.
Okay, sounds good. unless there are other questions, I don't see any, and no raising hands. Pierre, I thank you very much for your time.
You're welcome.
And thanks for this really good talk. We will put it out online on YouTube. So for those of you who are still, we lost a couple of when we went over 6 o'clock, but I'm hoping they will find our YouTube channel. And for those of you who haven't been there, of course, visit our YouTube channel and make sure you also visit the blog post that Pierre posts here, and we'll share everything. And again, thank you, Pierre.
Thank you, Tobias. Thank you. I really enjoyed that. Thank you so much. Have a great evening.